Free body diagrams show us the forces acting on an object. These are helpful to us as free body diagrams are used when studying dynamics. And dynamics is the study of what causes motions and what affects an object's motion. Some common forces include the force of gravity, normal force, friction, tension, applied force, and net force, which comes from Newton's second law of motion. When drawing free body diagrams, we use arrows to represent forces. Bigger arrows are stronger, and where the arrow points shows the direction of the force. Let's practice. First, we will draw the object. And the one force that is causing the pencil to fall is the force of gravity. We will draw an arrow to show that. The arrow for gravity will usually point downwards because gravity brings objects to the center of the earth. Next one. It will be quite similar to the first one, but this time there is another force acting on it. A small arrow up representing air resistance. Next one. I forgot to say we are pushing it right, but we are. It is being pushed, meaning there is an applied force to the right. But there is friction as well, opposing the applied force. This is shown by drawing an arrow to the left, and of course there is gravity and normal force because it is on a table. Here's another one. We know there is an applied down because it is stated that it is being pushed, so we will draw an arrow showing that. We also have friction, and we will draw an arrow that opposes the applied force. And since it is on a surface and not floating, of course we will include an arrow showing gravity. Lastly, the normal force since an object is on a surface. Remember, the normal force is perpendicular to the surface, hence we draw it like this. Last one of this kind of practice. In order for it to hang, the force of gravity has to be acting on it. The pencil is being hung, so tension is acting on it. Tension acts on flexible objects like string, rope, cables, etc. Now here's a problem pulled straight out of an actual test I wrote. Let's figure out the first scenario. Based off the text, we can assume it has both normal force and gravity because it is on a table. We can also assume it also has applied force and friction. This fourth one has all the forces, and the applied force arrow is the largest. This means it most represents the first one as you need enough force to overcome static friction. The second scenario only has two forces, normal force and gravity. No applied force, friction, tension, etc. because his phone is on the table, stationary. So out of all the options, the first one matches this scenario the best. It has no other forces other than those two acting on it. This third scenario involves a marble rolling down one of these things. So we can guess this problem's involved ramps. We looked at ramp free body diagrams and know that normal force, friction, and gravity is involved. No applied force though because it has not been explicitly mentioned here. Take a look at the second option. It has a normal force at an angle, which happens to create a 90-degree angle with an imaginary ramp, matches very well with our third scenario. Here's our last one. We can see the monkey is swinging on a vine, a flexible object. This means there will be tension. And of course, gravity. Here there is no applied force. The monkey is swinging because of the forces. No normal force as they are not on a surface, and definitely no friction. So it's this one. Yay, we have finished this.